Good evening, good evening, good evening. Welcome aboard all my warriors, all my minions, all my V enthusiasts, all the lovely students of 12th standard who are going to crack the examination next year. Welcome to the next session number 3 of potential energy and potential in the chapter of electrostatics in the Pathfinder series, which is targeting towards JEE 2022, that is the exam which is going to be conducted next year, and all the aspirants, be it JEE, be it NEET, be it boards, all are welcome here because we are going to lay the foundations. We are going to start from the basics, we are going to do the concepts, we are going to solve the problems for JEE Mains and JEE Advanced for the next year. All with me, Shreyas, your master teacher for physics at Vedantu. Hello everyone. Hi Munna Bhai, MBBS, Bhargav, Surya, Shreyas Kapri, Srinu, PL, Nancy, Yalini. Welcome Monkey, welcome Yashwant, welcome Aboor Yalini, welcome Marvin, welcome Kirtaran, welcome Rajni. Good evening everyone and a very happy Gudi Padwa. Very happy Gudi Padwa to every one of you out here as the beginning of the new year for all of us as well. Welcome aboard. And how was your day? How was your festival? So because the thing was, I didn't want you guys to skip the festival, so that's why I had to shift my class from yesterday to tomorrow. So tomorrow we are going to have our Zero to Hero series, which will be conducted at 7 o'clock. All right, so get ready guys. All right, so welcome aboard. Hello everyone. Hi Neelam. Hi. So everyone, hi Shivagi, good evening, good evening. So in case you want to know more about me and you want to check out the cool videos that I uploaded just in the past few days, in fact even I uploaded one more video today, do not forget to check it out on my Instagram handle, that's Shreyas_Vedantu. And before we begin, do not forget to hit the like button and do not forget to hit the subscribe button, because if you are new and if you do not hit the subscribe button, then you will miss out on all the amazing lecture series that we have planned for you. So please go ahead, hit the subscribe button for free of cost, and yes, please show us your support by smashing that like button out there. So a lot of you out here are in 12th standard. Hello Surya, hi Amu, hi Ashish. Okay, tomorrow is my bomb day, sir. Bomb day, I'm guessing it's birthday. All right, that was a misspell. Hi Ankit, thank you for all the love again. Hello. What about electric field due to continuous charge distribution? Arishish, we're going to do that. Don't worry, we're going to do that. Electric field due to different geometries is going to come once we learn Gauss's law. Don't worry about it. Okay, thank you, Yalini. You saw that. Very good. Wow, Vijay Kumar, glad to have you back. Thank you. With all the hearts, you're back. So, guys, remember, it's a long process because it's not an easy process. For this next 1 year, you're going to have a lots of ups and lots of downs. And it's very important that you stay focused, you stay determined even during your downs, because remember, whenever there is a down, you're also going to have an up. And all those people who give up, all those people who think that they cannot do, or maybe JEE is not for me, actually will not clear JEE. But if you stay focused and if you plan everything systematically, if you attend all our classes over here, so guys, we are doing our classes on YouTube as well as on the Vedantu platform. So for those of you who cannot afford the platform, we are always there on YouTube. And those of you can afford the platform, definitely please go ahead and check out all the details, because it's very important that you stay focused and you do not waste your time, because a lot of you have already realized that, oh, I have wasted my 11th standard, oh, I did not study fully in my 11th standard. So I'm pretty sure you do not want to say the same thing next year again. So if you believe in yourself, I'm pretty sure you can do that, guys. And somebody asked me on Instagram just a few days back, and they were like, sir, I'm an average student and I did not study so much in my 11th standard. Can I really crack it? My answer to them was, guys, please understand, there is nothing like an average student. There is nothing like a super duper topper student. There is nothing like a below average student. Guys, if you work hard, believe me, you can crack it. I don't know how many times to say this, but a lot of people have this misconception in your head. How many of you have it? Let me know in the chat box. How many of you think that, oh no, this JEE, it's not for me, it's for him. oh, this physics, it's not for me. Oh, it's for them. Oh, they keep discussing something about black holes and supernovas and all. Oh, I don't understand it. Oh, I don't know what is quantum physics. Oh, maybe I'm not good at physics. Oh, I'm not good at calculations. Maybe I'm bad at maths or something. So guys, if you get scared looking at other people, trust me, you will remain scared. So please understand, stop looking at those negative people. Start, mingling around with like-minded people who are at similar stages, and as a group work together so that all of your group mates, all of your friends together can crack the JEE exam. Because understand that, yeah, some of you are saying me, some of you are not saying that, you're not like that. Good, some of you are not getting demotivated by looking at others, so some of you are. So guys, remember, if you have the right group, I'm pretty sure you can actually crack the examination, because from my past experience I have seen a lot of students in fact get into JEE, crack the JEE examination, get into IITs as groups, not as individuals. So form a beautiful group, trust me, you can crack it out there. And if you want to get onto our platform also, you can do that. And in fact, if you see our results also, like look at this, 307 students above 99 percentile, between 97 to 99 percentile in Vedantu there were 535 students, and above 90 to 97 there were 686 students in the JEE Main 2 attempt. Come on, this is the March attempt. So it's like, the new address of all the toppers. 100 percentile, there were many students, 11 students in physics from Vedantu got 100 percentile, 6 students got 100 percentile in maths, and 2 students got 100 percentile in chemistry. That's a big thing. I think if you were there in front of me, I would definitely ask you to give you a big round of applause for all these students out here. In fact, if you see the conversion ratio, almost 1 in 2 students has cleared mains for JEE Advanced from Vedantu, almost 1 in 2 students. That's a big number out there. So guys, if you definitely want to check out our Vedantu platform, do check it out, because the link is there in the description box below. And the course is being offered at 10% off when you use the coupon code SSHPRO. So do not forget to check it out, so that you stay focused for the next 1 year, and you can join the long-term batches which is going to start this week. So please do not forget to register yourself. Check out all the details using the link in the description box. Now, let me talk about Sanket JEE 23 series is also going to start. Alright, so don't worry about it. We are going to start with JEE 2023 series as well. Yes, we're going to start with a bridge course slowly from next week, not this week, next week. Okay, so don't worry about it. Yes. Oh my god, monkey, people get demoted looking at you. That's scary and interesting at the same time. Now, remember last lecture we have spoken about field and forces. Now today we are going to talk about energy. We are going to talk about potential energy and potential. Now for doing that, I have taken the example of monkey, and monkey is saying, yeah, that's me. Yes, monkey, that's you. Okay, so look at this monkey. What is it doing? It's carrying a charge, positive one, and it's moving towards another positive charge. Obviously there is going to be a strong repulsion, and the monkey leaves that charge over there. As soon as the monkey leaves the charge, because there is repulsion, the charge just flies off. So the monkey did work or no? Yes or no? Yes, it's a monkey. Yes, guys, yes, monkey D. Luffy, that's monkey D. Luffy on the slide. So did the monkey do work in bringing the charge close to another positive charge? Yes or no? Let me know in the chat box. Did the monkey do work in bringing this positive charge from here to here? Yes or no? Yes, come on, think about it. All right, yes, the monkey also replies. Yes or no? Yes, the monkey did work. Yeah, the monkey also says yes. Very good. So, because there was repulsion. Now when the monkey leaves the charge flies off. The charge flies off. Now the moment the charge flies off, that means the charges had some kind of potential energy. So whenever you have a system of charges, whenever you have a system collection, charges are around each other, and you leave them, they will start rearranging themselves, they'll start reshuffling. That means they have electrical potential energy. Just like over here, look at this, another simulation out here, look at this. So this dude, I don't know, maybe monkey, maybe somebody else, I don't know, some pandu, he brings those charges and he just releases one of the negative charge. This has more positive and less negative, so this is another negative charge. So he has to actually do work in bringing these charges over here, because actually there is attraction between them, so opposite charges, so he has to do work. But if he releases this positive charge, you can see that it flies off, because these positive charges will repel each other. So you can see there is always some ability, some energy stored, that ability to perform work because of its configuration, because of its arrangement, because of the nature in which, or the manner in which they have been placed or arranged. That energy is called as electrostatic potential energy. Yes, I hope this is clear. Very good, Sarvesh. You have come prepared from Resnick and Halliday book. That's a very interesting book as well. Has everybody understood this? And please write down this definition. Although you will get this definition in your notes from our Telegram group. So if you are not a part of our Telegram group, please do not forget to join it using the link in our description box below. So electrical potential energy of a charge at a point is defined as the amount of work done by the force from outside, that's external, in bringing the charge from a reference point to that point without any acceleration. Now let me explain this to you. Alright, this is in a little bit complicated way, but let me explain this to you. Okay, now just imagine, guys, let's just imagine. Okay, so we have this charge Q1 over here and this charge Q2 over here, and there is some separation R between them. Okay, there is some separation R between them. So I'll say for separation R, all right, the potential energy is U. When the separation between the two charges is R, the potential energy is U. Now for infinite separation, understand, when the separation is infinity, the potential energy is assumed to be, what do you assume the potential energy when the charges are separated by infinite amount? Come on guys, answer in the chat box. Come on. So do we have to follow this or the old video of the same topic? Vikram, flash series was more like concise, like a revision part for all the previous year students. Now you have to follow the Pathfinder series, not the Flash series, because in Pathfinder series we are going to cover, it's a long-term course which we are going to cover all the chapters, all right, in detail with examples, concepts, etc. All right, tends to 0. Yes. Okay. Yes, Himanshi, this is going to cover, this is going to continue like a regular course, long-term course, and I also teach on the regular Vedantu platform, including the micro courses which are present on the Vedantu platform. So you can find me over there as well. Yes, it tends to 0. Very good. It will be 0. Very good. So this is what it says. There is a reference point. So with respect to infinity, it has some potential energy. Remember that. Always energy is measured with respect to some situation, with respect to some configuration. If you recollect, in 11th standard, gravitational potential energy was assumed to be 0 at a certain level, and when you remove that block and move it somewhere else, then the potential energy changes by mg delta h. So always you assume some level or some situation or some configuration as 0 energy, and with respect to that configuration you always end up measuring the energy. So as a standard, what have we assumed the reference to be? The reference is infinite separation. And what is the reference potential energy? It is 0. So with respect to 0, when the separation is infinity, the potential energy right now is U. Understand that the potential energy is U with respect to large separation. Guys, now answer this question quickly in the chat box. Let's see who will answer this quickly. If two positive charges are very, very far away and I bring them closer, if two charges positive are very, very far away and I bring them closer, will their potential energy increase or will it decrease? Or will it become positive or will it become negative? Remember, it was 0 at infinity, and I bring them closer, what do you say, guys? Will it increase and become more positive, or will it decrease and become more negative? Come on, guys, let me see how many of you are able to answer this. Thank you, nothing, peace. Come on, come on, come on. Infinite separation, zero potential energy. I bring them closer. So what do you think? Is it going to increase and become positive, or is it going to decrease and become negative? All right, come on, think about it. Well. Think, guys. All right, Vijay Kumar, now you'll understand it. Now there are two positive charges very far away, right? Now if I bring them closer, I will have to push them against their own will, because they actually want to repel. Think about it. Two positive charges, I have to push them. I'm like, okay, come closer, come on, because they want to repel. So I have to do work on those charges. Now, whatever work I do, I am using my effort, I am using my energy. I ate a vada pav outside, and I am using my vada pav energy to, bring these charges closer and closer. So that means my energy is getting stored in the form of potential energy between the charges, because the moment I leave those charges, they'll be like, okay, let's move. Tuck, they'll just move away. So there was potential energy stored between them. So hence, understand, when you bring those two charges closer, positive charges, then the potential energy increases and it becomes more positive. Understand that. I hope this is clear. Yes, it's opposite in case of gravitational potential energy. Correct. Now, I have a simple way of, understanding whether the potential energy increases or it decreases. Remember one thing, whenever the potential energy is high, all right, you will be sad. So when the so this is basically high potential energy. So whenever the potential energy is high, you will be sad. But the moment potential energy decreases, you will be very, very happy. So this is low potential energy. And everything wants to be happy. Who wants to be sad here? Does anybody want to be sad? Obviously no. So you want to be happy, you want to be always in lower potential energy. So whenever something is brought against its will, whenever you do something against its will, that means the potential energy will increase, because you are making it more sad, against the will. You are watching a match and somebody drags you outside the TV room, you will be sad, you will have high potential energy. You have been taken to an amusement park, or you have been taken to a movie, you will become really happy and your potential energy will be lower. I hope this is clear. No, you are not sad, Kirtharan. All right. Yes. Yes, Himanshi, probably there might be some delay, because first of all, my video will reach you after 10 seconds or 15 seconds, and your chats might reach me after 10 seconds or 15 seconds. So, totally if you add it, probably half a minute delay or 20 seconds delay out there. Okay. Now, having said that, so this is very important. This is something you should keep in mind. Very, very important diagram. Please let it be there in your notes. And the last formula, just like in gravity, the formula for potential energy. What is the formula for potential energy when the separation is R? Well, let me write it here. It is equal to K, be careful, Q1, Q2 divided by R, not R square. Be careful. Yes, that's the formula, guys. And this is something, again, you should remember. Please remember this. K, Q1, Q2 by R. In gravitation, it was minus G, M1, M2 by R. So that minus G is not there. You have K. Is that understood? Now, think about it. If any one of the charges is negative, what will happen to the potential energy? Come on, guys, answer in the chat box quickly. If any one of the charges is negative, then what will happen? And if both the charges are same sign, then what will happen? Think about it. If both the charges are of opposite sign, the potential energy will be, come on, answer in the chat box. Come on, minions, come on, everyone, come on, we enthusiasts, come on, warriors, come on, everyone. Yes, think about it. What will be the potential energy if the charges are in opposite sign? Yes, it will be negative. And if the charges are of same sign, then the potential energy is positive. Negative is positive, positive is also positive. Keep this in mind. All right, very good. Excelente, excelente, guys. Let's move ahead. I hope you have noted down this formula because it's going to be useful for the next few problems. Now, yes, very good, Bhargav, very good, Shivangi. Okay, Rajiv, बाद में बात करते हैं. Let's think about this later on. First, let's focus on the session. Okay, cool. Yes, very good, very good. Now, let's see some properties of potential energy. Again, all of these things should be in your notes. The unit of any kind of energy, potential energy, gravitational potential energy, spring potential energy, electrical potential energy, magnetic energy, energy stored in vada pav, energy stored in idli, energy stored in pizza, energy stored in chocolate, energy stored in candies, energy stored in dairy milk silk, energy stored in Oreo. Everything has joules as the unit. Come on, at the end of the day, it's energy. All right. Next, it's a scalar quantity. So you just have to add it. You don't have to worry about the directions. Energy does not have direction. You just add it. This has 10 joules of energy. Then it got 20 joules of energy. So 10 plus 20 is 30. You don't have to worry in which direction the work was done. All right. Very good. K can be negative. No, Bhargav. K is always a positive number. Yes, it is 9 into 10 to the power 9, the Coulomb constant. 9 into 10 to the power 9 for SI units. All right. Okay. Next important thing. Yes. My God, look at that. Anish talking about chicken biryani. Oh my God, Bhargav. Yes, 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 yes. Looks like people are already hungry. Now, when you have more than two charges, then understand the total energy of the system. 4 charges, 5 charges, 6 charges will be the sum of this energy plus these two energies plus these two ka energy plus this energy plus this energy plus this energy. So all the charges combination, these two, that two, these two. If there are 5 charges, again take all the 2 charges at a time and add their energies. You get the total energy of the system. I hope this is clear. Oh my God, Yalini started crying already. Okay, great. Oh my God, today's Gudi Padwa. You're not supposed to eat meat, guys. All right. Okay. Yes, monkey got caught. Monkey, you should eat bananas. Only bananas today. No, nothing else. Okay. Chalo, let's get going to the next point. Okay. The electrostatic force and potential energy is related by the most famous relationship of work energy from 11th standard. Relation between, what's the relation between potential energy and force? Are they husband wife? Are they boyfriend girlfriend? Are they brothers sisters? What is the relationship between electrostatic force and potential energy? In fact, any energy, potential energy, and any corresponding force has the same relationship. F is minus du by dr, the most famous relationship out there. Now let's remember that. Okay. Cool. Yes. So that's the answer, guys. F is equal to minus du by dr. Standard relationship. You should know this. You have learned this in work power energy, guys. Keep this in mind. In fact, sometimes this can be also useful in other ways. You can write du is equal to minus f dr. You can write it like this, and if you want, you can again integrate this. So integral du is minus integral f dr. So this is how you can use this equation either in derivative form or in integral form. Both are the same things. It's just rearranging and putting an integral out there. So force is negative du by dr or minus du by dx. I think you know this from your 11th standard. Okay, so keep this in mind and remember all these pointers. Okay, let's start with some questions. Let's see how many of you can do this. Okay, cool. Let's do this question. 4 charges are there and they are arranged on the 4 vertices of a square. The question is, what is the energy of this system? If these 4 charges are placed, they have some electrical potential energy because they have ability to do work. Let's figure this out. Why negative sign? Okay, why negative sign, says Shivangi in the previous thing. I'll just tell you guys. Basically, it comes from this logic. Work done by conservative force is negative du. This is basically the standard original formula, and work done is force into displacement. So that's why you get this, and from that you get F is minus du by dr. Now you might be wondering, why the hell is there minus sign over here? Well, there is a logical reason for that. For example, I am standing here and I lift a vada pav. Okay, I lift a vada pav up like this. This is my vada pav. All right. Okay, this is my vada pav. Okay, so if I lift the vada pav, the potential energy, all right, the potential energy increases by 10 joules. Example, the potential energy increases by 10 joules. Understand this? Now, how much work will gravity do? Gravity will exactly suck away 10 joules. So work done by gravity will be minus 10 joules. Why? Because whatever I will do, I will be doing some work, all right? I'll be doing some work in lifting that vada pav. Gravity will suck it away because force of gravity is down, displacement is up. It will suck it and it will store in the form of gravitational energy. So you can see the relationship between change in energy, potential energy, and the work done is negative. So that's why the sign. I hope this is very clear. Oh my god, HSR, yes, I know you from my previous year batch student. So I hope you can also continue watching my sessions out here. Yes, in case you want to do so. Welcome, HSR. All right, so now that is clear. Yes, let's get going to the question. Yeah, let's see how many of you have got it. Some of you have already got it. Very good. Kirti Haran have got it. Excellent. So guys, what you need to do is potential energy between 1, 2 plus potential energy between 2, 3 plus potential energy between 3, 4 plus potential energy between 4, 1 plus potential energy between 2, 4 plus potential energy between 1, 3. So all the combinations have been taken. Now each one will have K, Q, that is Q square by 1 and 2. What's the distance? It is L. So even this will be the same. It will be again K is Q square by L, because these two and these two all have the same separation L. So KQ square by L plus KQ square by L plus, now 2, 4, all right, 2, 4 and 3, 1. The separation between them is root 2L, because if this is L, by Pythagoras, this is going to be root 2L, keep that in mind. So this is going to be KQ square by root 2 times of L, and again you're going to have KQ square by root 2 times of L. Now take LCM, oh sorry, no need. Actually take out few things common, like KQ square by L is common. 1 plus 1 plus 1 plus 1 is 4. 4 times of 1 plus 1 by root 2 plus 1 by root 2 is 2 by root 2. That's it. Now root 2 cancels. You're going to get root 2 over here. All right. And that's the answer, guys. That's the answer. 4 plus root 2. Yes. Y Q square K Q1 Q2. Remember, monkey? Energy is K Q1 Q2. That's why K Q Q. That's why Q square. Yes. Okay. Okay. Come on. Think about it. Very good, Shivangi, glad you understood it. Hi Pooja, good evening, welcome aboard. Very good, Kajal has got it. Excellent, guys. Yes. Okay, no problem, baby. Luffy world, no problem. Okay, great. Yes, HSR, I'm going to take 12 batches for Sankalp. I'm taking the toppers batch already for Sankalp, and the other things that I'll be taking, HSR, is the, the micro courses. So a lot of micro courses is what I'll be taking. Yes. Yes. So where is that L? L has been taken outside. Remember that L has been taken out common. Okay, Anish, vampire. I hope you understood. I've just taken out the L common. So 2 times, actually this was 2 divided by root 2. So what I have done is basically I have cancelled this root 2 and this 2, and I have written root 2 over here. That's all I have done. So that's the final answer. Okay, I hope now it is clear. Okay, so that's the answer, guys, like you can see on your screen. Get ready for the next question coming up on your screen. Okay, beautiful question. All 4 possible scenarios. First time you have 2 like charges. That means positive or negative. Second time you have unlike charges. Okay, so just think about what will happen to their potential energy. The question is, what will be the potential energy? Yes, HSRs, I'll see you there soon. Okay, I'll give you a hint. The hint is, if you're happy and you know it, clap your hands. No, don't clap your hands. Okay, if you're happy, then you know that you have high potential energy, and if you have low potential energy, then you are, oops, sorry, my bad. If you're happy, then you have low potential energy, and if you are sad, then you have high potential energy. Remember that. And everybody wants to go from you want to be, you want to be happy by getting low energy. That's what the logic is. Come on, think. Attractive potential energy will be negative, and negative for repulsive. I don't know. Let's see, Sarvesh. The question is whether it will increase or decrease. The question is whether it will increase or decrease. So think about it. The fill in the blanks. Come on. Fill in the blanks. Come on. Think. All right. Come on. It was from a meme. Oh, is it? Okay, increase. 1 is increase, 2 is increase. I don't know. Let's see. Okay, just think about this. Two like charges. Okay, two like charges. If the distance between them is increased, they want to go away. They'll be happy to do that. They'll be like, oh, you want to separate us? All right, I'm anyways ready to do so. I will do it by myself. Like, oh, that positive charge, I'm going to repel that. So it's going to go away as it is. So it's going to be really happy about it. So the potential energy will decrease. Understand, it will decrease. Correct. Now, okay. Second, if the distance between them is decreased, you bring two positive charges close by. They are not going to like it. They are going to be really sad about it. They are going to make a lot of fuss about it. Understand that. So two positive charges brought close together, they are going to be sad because they want to go away. Hence, the potential energy has increased. All right. Yes, Himanshi Prajapati has got that. Now, let's see whether you get it for the second part. Remini says increase and decrease for the second. Yes, obviously it has to be opposite, but let's think about it logically. Come on. Let's think about it logically. Unlike charges, so this is positive and negative. If you take positive and negative, Pandu loves Champa. Think about it. This is Pandu, this is Champa. Pandu, Champa. You separate Pandu from Champa. Are they going to be happy? Obviously not. They are going to be sad. And if they are going to be sad, then think about it, the potential energy will be high. Correct? So it's going to increase. The potential energy is going to increase. And if you bring Champa and Pandu close together, they are going to be really happy about it. And if they are going to be happy about it, they have low potential energy. That means the potential energy has decreased. Yes, correct, inversion. But I hope you guys understood. I hope you guys understood the underlying principle. Do not say, sir, if it is decrease increases here, then it will be increase and decrease over here. Don't do the opposite way. Just think from the basics, and this diagram helps you do that. Yep, let's get going. Very good, guys. Excellente minions, excellente V enthusiasts, excellente my warriors. I'm loving this. Very good. Shall we go ahead? Let's get going. Now let's do this. Very good, Fatima. Thank you. Okay, and here it is. Very good, Premani. Okay, well, now you have a 2 coulomb charge and a 2 coulomb charge. Positive. The red one is a negative 1 coulomb charge. Now you do not move these 2 coulombs. Those orange ones, keep them as it is. Only this central negative charge, you start moving it and throw it to infinity. The question is how much work needs to be done to move this charge and throw it to infinity. Okay, think about it. Let's do this. Aditya Raj, you can do one thing. You can repeat or replay the same part wherever I explained again. So that's the advantage at YouTube live sessions. You can repeat that part, whichever you did not understand, again 2-3 times. Don't worry. All right. So explanation will be there as it is. Okay. Hi Anushri Kashwell, welcome aboard. Thank you, Pathak Dinkar, loving the session. Thank you so much. Oh yes, Usha, I already, okay, thank you for reminding me to have water, or maybe, I don't know, is it a sanitizer or what? Okay, so let's try and do this problem. Let's try and do this problem. Let's see how many of you can actually do it and give me the answer before I show you the final answer. Come on, let's see how many of you can do this. Come on, minions. Come on, my warriors. Let's do this. I want to move this charge away. Guys, will this charge like to go away from these two positive charges? Will it like or will it not like? Answer in the chat box. Do you think this -1 coulomb would love to go away from these two positive charges, or will it be against its will? What do you guys think? Think about this. Come on. Come on, my warriors. Think about it. What do you guys say? Do you think it will like to be away, or will it not like to be away? Think. No, it will not like to be away, or will it like to be away? Think about it. It will not like. Very good, Kirtaran, very good Rajani, very good Rishi, very good Fatima, very good Shivangi. It will not like. So you have to do work. You have to do work. That means the system will have some initial energy, all right, plus you do some work, that will go into the final form of the potential energy. It will have some initial potential energy right now, and you do some work that will be equal to the final energy. As simple as that. Energy conservation principle. Initial energy plus my work done will be the final energy. As simple as that. Now what is the initial energy? Well, this 2 and -1 will have energy. This -1 and +2 will also have energy, and this +2 and that +2 will also have energy. So 3 things will have potential energy. So potential energy between 2 plus potential energy between 2 - 1 plus potential energy between again 2 - 1. I hope you guys get it. 2 and -1, 2 and -1, 2 and 2. All right. Plus the work done will be equal to final energy. So when you take this charge infinitely far away, what will be the energy between -1 and +2? When this charge goes really far away, that -1 and +2, what is the energy going to be? Think about it. It will be 0, right? That -1, which is very far away, and the +2 coulomb will be 0. Same thing between that same -1 coulomb and that +2 coulomb, infinite separation. So again 0. I hope you see that. Yes, I hope you see that. Thank you, Pooja Batra. Very good. And now, very good, Himashi. Now, the potential energy between 2 and 2 will be there still. Potential energy between 2 and 2 will still be there because they are still at the same distance. Correcto. Now, do you see, guys? There's a very interesting thing that is happening. There is this U22 term over there, and there is also this U22 term on the left hand side. So, don't you see that these two terms are going to get cancelled out over there? This term and this term on LHS and RHS is going to get cancelled out beautifully. Now what you need to do is, what is the energy between this and this? Oh, that's simple. It's going to be K into 2 coulomb and -1 coulomb. So 2 into -1 divided by, what's the distance between them? Well, the distance between the 2 coulomb and 2 coulomb charge is 4 meters. So this is 2 meters and this is also 2 meters. Alright, this is 2 meters, that is also 2 meters. So this will be 2. I hope this is clear. This is going to be 2. So the second step, Jay, what I have done, initial energy is the sum of, remember, whenever there are 3, 4 charges, what will you do? You will take all the combinations. Remember that? That's what I have done. So the initial energy is these two energy, these two ka energy, and these two ka energy. So all the energies in pairs, I have just added them. So 2, 2, 2, 1, 2 minus 1 and 2 minus 1. Alright, that's all I have done. I hope now it's fine. Okay, so can you repeat how U final of charge 2 and -1 is 0? Munna bhai, the reason why this is 0 is because there is infinite separation. Remember, when the separation is infinity, what did we assume? Energy was 0. That's why it is 0. I hope this is clear. Okay, now what I want to tell you guys is that if this much part is understood, the potential energy between 2 coulomb and -1 coulomb charge, between 2 and -1 coulomb charge is this much. Again, between this 2 coulomb and -1 coulomb charge will be again K into 2 into -1, again divided by the separation plus the work done, and the RHS is anyways going to be 0. Now what are you going to get? You're going to get, yes, check this out guys, this 2 and this 2 is going to get cancelled. Do you see that? This 2 and this 2 is going to get cancelled, so you're going to get -2k. So -2k plus W is equal to 0. Therefore, W is equal to 2k. Now, what is k? K is nothing but 9 into 10 to the power 9. I hope you know this. 9 into 10 to the power 9 SI units. So, this is going to be 18 into 10 to the power 9 joules. That's the answer. Is everybody understanding this? Understood this? Okay, yes, yes, that's what you're going to get. Remember, this 2 and this 2 got cancelled, this 2 and this 2 also got cancelled over here. In case you didn't realize that, this 2 got cancelled, this 2 got cancelled. Minus k is -2k. That's what I got. Very good. Excellent. So that's how you solve the problems on energy, and this is the kind of questions that you will get. Why didn't you write 2 - 2 first, sir? So 2 and 2 means potential energy between 2 coulomb and 2 coulomb. This is not dash, this is -1. Between 2 coulomb and -1 coulomb. So this is between 2 coulomb and +2 coulomb. Alright, this is also between 2 coulomb and +2 coulomb again. Okay, I hope Vatsal, you understood it. Okay, yes, such a big value because the charges are also very big. 2 coulomb, 1 coulomb is an extremely high value of charge. You will not find it around you, and if you find it, trust me, if it passes through your body, you are going to die. Okay, yes, I hope this is clear. Okay, let's get moving. I hope Ashwa, you have understood, and in case you did not understand any particular step, please watch the replay of it, bacha. Alright, that will help you. Okay, so Aditya Raj, in fact, we have a better platform than the smart board on our wave platform, on our regular platform. It is called as a wave. So this does not have the ability for quizzes, for leaderboards, for chat handling, for doubt handling from our secondary teacher. So on our regular paid platform, we have all those functionalities which can be embedded, which cannot be possible on YouTube. So that's why, you know, we tell you that you should check out our standard wave platform, which has all these functionalities. Leaderboards are there, lot of polls are there, yes no kind of questions, so right, quizzes are there, chats, regular chat section, we can moderate the chats, there is a class teacher, you can ask doubts, so many other things. All right. Yes, how did you get the values 2 into 9? Anish, that's a standard value. K's value is 9 into 10 to the power 9. That's why. Okay, standard value. Remember, past lecture I have told you all of this. Okay, now, yes, now, the thing that we will have to talk next is potential. Now, you might be wondering, what the hell is potential? Yes. Oh, well, it depends, Aditya. You have not yet tried on the regular platform. Maybe you should put in a sincere effort. Trust me, you will understand it even better on our wave platform. That is beautiful, trust me. Okay, so probably you should check out some of the micro courses where I teach. You will love it then. Okay, yes. Now, yes, video call is also available in Vedantu. I can unmute students. We can also do a conference. We can I can have all the videos of all the students out there, and we can all interact with each other. So all those things are possible. Okay, now this is not a wallpaper, guys. This is actually basically the field and potential diagram of charges. Remember, we have talked about field in the last session. Now, field is something which is created around any charge or system of charges. So, similarly, every field also has something called as the potential. Now, you might be wondering, what the hell is potential? Potential is the ability to gain potential energy. Potential is the ability to gain potential energy in simple terms, if I have to put it. Now, I'll give you an example. I'll just give you an example, okay? All right, so here we go. I have this nice pen stand out here, and if I ask you guys, does this pen stand and my earth down there, does it have potential energy? Come on guys, help me with this. What do you think? Does this pen stand and the earth have potential energy together? What do you guys say? Does the earth pen stand system have some kind of potential energy? Yes or no? Come on, come on, come on, warriors. Come on, all my warriors. Let me know in the chat box. Does it have potential energy? Yes or no? Yes or no? Come on, come on. Akshay Pyala, I will definitely help you out after the session is over. Please let all your comments be posted after the video ends in the comment section. Yes, it will have potential energy. Now I make this disappear. It's gone. It's gone. Nothing is there. Nothing is there. All right. Now, if nothing is there over here, does it have potential energy? Does Earth, with respect to this point, have potential energy? The answer is no. Because what will it have potential energy with respect to? Because there is nothing over here. But it has the ability, the औकात, तेरे में औकात है क्या? Do you have that in you? Do you have that fire in you? औकात. So, does it have that औकात? Does it have that ability? Does it have the capability to get potential energy if I place something over here? Yes, it has that ability. Yes, it has that ability. But if I disappear this, Shreyas the magician. All right. So, if I disappear, if there is nothing, then there is no potential energy, but there is potential for getting that potential energy. Same way, guys, electrical potential. Let's define this. Let's define this. Yes, this is potential, not energy. It's not actually there, but it has the ability to get that energy. Understand the difference? Yep, double magic. All right. Imagine you have a system of charges. This is some system of charges. And you are at some distance from this. This is some distance from the charge. And let's say I take this point over here. At this point, there is nothing. It's empty. It's vacant. Nothing is there. What will be there over here? Yeah, field will be there. Even potential will be there. Potential is there. Potential energy is not there. Understand that. So at that point, nothing is present. Nothing is present. Do not forget that. If nothing is present, potential, yes, it's there. Potential energy is not there. V is the symbol for V, Enthuse, Vedantu, and also potential. U is the way in which you should smile, and that's the potential energy symbol as well. Okay, potential is there, potential energy is not there. So to check whether actually so guys, if you want to check whether there is potential or not, it's just like this is your gunda, this is your bully in your class. There is a big gunda sitting over there, okay, in your class. You want to check, does that bully have some potential or not? What are you going to do? You're going to slowly walk. And you're going to be like, and if he looks behind and he gets angry, you know that he has potential. Correct? So you're not going to disturb him too much. You're not going to be like, he is going to take something, I don't know, he's going to take something and he's going to hit you on the head. So you do not want that. So you're going to be very careful. You're going to be like, okay, he has potential, let me just run away. So you need a test charge for all of that. Yes, you're going to need a test charge over there. So you put a test charge, but what kind of test charge? Well, a positive one by convention, but infinitely small test charge so that it does not affect these charges. So that it does not, yes. Do not kick him, do not throw a duster on him. He will get affected, he will come back to you, he'll charge at you. Yeah, you do not want that. So infinitely small test charge, that's what it happens, guys. Yes. Yeah. So difference between potential and potential energy. If there is potential, then energy should be there na. Wrong, Himanshi. If there is potential, there may not be potential energy. If you actually put a charge, there is energy. If there is nothing there, then there is just a concept called as potential, where there is an ability to get energy, not actually energy is present. Yes. So guys, understand Potential is defined as energy per unit charge limit Q tends to 0. Limit Q tends to 0. Very, very important. You should know this formula. So guys, you can guess the unit from here. So the unit is up, you have joules, bottom, downstairs you have coulomb. So joules per coulomb. And remember, joules per coulomb is also known as volt. Yes, 1 volt is 1 joule upon 1 coulomb. Remember this, 1 volt is 1 joule upon 1 coulomb. Keep this in mind. Yes, like chicken coconuts. Okay, I hope this is clear. And yes, this is also a scalar quantity, just like before. So this is how I define potential. Very good. So write it down, guys. Very, very important stuff on your screen. Infinitely small positive test charge is needed. Yep, to check whether there is potential or not. Remember, the test charge always has to be very small and it has to be a positive one by convention. Remember that. Very good. Okay, so if you don't know limits, don't worry, Sanket, you are going to learn it, and I'm guessing in 11th standard it should have been taught to you at least the basics of it. But don't worry, limits means something which is approaching something, that's all. So limit Q tends to 0 means the denominator becomes very small, because I want this charge Q to become very small. That's it. Okay, don't worry, Sanket. Okay, cool. So you will eventually learn it in maths. So for now, just understand, just get the sense out of it. You don't have to know the literal meaning. Okay, yes. Yep, Vikram, we are not going to call it Pathfinder, we are going to call it something else, Vikram. Pathfinder is for 12, so we are going to definitely have 10 to 11 series also. Yep. Now, remember, unit is joules per, oops, my god, why is there joules over here? This should be joules per coulomb, my bad. Let me just change it. This is joules per coulomb, which is nothing but volt. It's a scalar quantity. Every charge creates a potential around it. Remember, positive charge will create positive potential around it, because you know everything around it will be having positive potential, and negative charge will create negative potential around it. I hope this is clear. Okay, yes, I just answered you, Vikram Nirmal. I don't know whether you are listening to it. Okay, I've just answered your doubt. Okay, so keep this in mind. Positive charges create positive potential, negative charges create negative potential around it. Keep this in mind. Okay, now let's do these derivations. Yes, let's do the derivations. Due to a point charge Q, what is the potential at a distance r from it? So at a distance r from it, what is the value of potential? So you place a test charge. So this Q is nothing but a test charge. Keep this in mind. Okay, so the potential due to a point charge at a distance r will be given by, start with the definition. What is the definition of potential? It is limit, all right, Q tends to 0, correct, Q tends to 0, U divided by Q. Now, what is the formula for U? What is the potential energy formula between two charges? We just saw that it was K, Q1, Q2 divided by R. That was the formula for U. But it has been divided by small q again. So put that small q over here. Now you can see this q and this q gets cancelled. And you are taking the limit of small q. But small q is not at all present over here. So when it is not present, the answer will be just kq by r. So remember this. This is very, very important. Remember guys, very simple rules of limit. Limit of, okay, for example, limit of x plus 3, where x tends to 0. Limit of x plus 3, x tends to 0 will be 3. Because when x becomes very close to 0, the value of x plus 3 will become 0 plus 3, which is 3 only. But limit of y plus 3, okay, where x tends to 0. Understand there is no x only in the answer, or there is no x over here. So hence the answer for that will be y plus 3. So same thing has happened here. When I took the limit, I was taking the limit of small q. There was no small q in this expression. So hence as it is, it will come out. There is nothing whose limit should be taken up. Yes. So Sakshi, for droppers, you should attend both Pathfinder as well as the 10th to 11th moving series as well. Plus on Vedantu platform, we are going to have dropper batches as well. And Sakshi, I feel it is too early to take a drop. If somebody has told you to take a drop already, they have fooled you. Okay, so please understand, exams are not over yet. All right, there are multiple attempts left. So please do not think about drops so soon. In fact, JEE Advanced is in July. All right, so I'm not sure why you're thinking about drop. Okay, so please don't think about drop. Yep. All right, let's get going to the next one. Potential due to a point charge was done just now. Okay, come on, let's do this. Next, potential due to a ring. Potential due to a ring. Guys, are you loving this Pathfinder series? Are you guys enjoying this Pathfinder series? Do you want this to continue? Do you want this to grow? So please, first of all, show your support. Few things I'm asking. Guys, on YouTube, there is no fees. All right. On platform, yes, you have to pay because you're going to get a lot of additional things apart from whatever you get at YouTube. But the only thing at YouTube I ask every time for all of you is, yes, your support, your love. And how do you show your love and support? By smashing that like button. And if you're new, please hit the subscribe button. Please do that. Because if you do not love our videos, if you do not show it, if you do not put comments, and if you do not subscribe, then I will be really disappointed. I want to see all your Enthuse coming through those things. Plus, you have to be the mascots. Get in your friends. Get in your cousins. Tell them Shreyas Sir is here. Tell them Shreyas Sir has already launched 11 to 12 standard series. Do not wait. Do not hesitate. Join in because this is an English medium channel. And I know a lot of students out there in our country and beyond our borders are studying in English medium and they do not have a good YouTube channel. That's why we have started this, and we want this channel to cross, the sky. The sky is the limit. I mean, come on, think about it. Yes. It's for NEET as well, Himanshi. Yes, if you're a NEET aspirant, I never differentiate, let me tell you that. So, physics is physics. The potential due to a ring formula will remain the same in NEET as well as in JEE. What will differ is the pattern, the difficulty of the questions. That's all. Okay? Very good. Thank you, Shivangi. Thank you, Kajal. Thank you, Keshav, so much. Thank you, Monkey. Your friends are already here. Don't worry, Ankit. Just like you have a logo for Neha ma'am, you should also have a logo for me, and I'm going to come up with it very soon. Don't worry. Okay, cool. Yes, Keshav, let's do this. Yup, I know Kirti Haran 500 subs in the last few weeks, and we are going to grow even more. Don't worry. Yep. Yes. The sky is the limit is an indirect way of saying that, we are going to reach even beyond that. Okay. So, all right. Now, because of a ring, what is the energy? Let's do this. First of all, I want to say, okay, let's just assume some distances. This is X. This is nothing but R. Okay, this is nothing but R. I want to find the potential over here. Here is what I will do. I will divide the ring into small dq charges. Okay, see what I have just done. I'll just tell you what I have done. So, imagine this is my ring. Okay, I divide the ring into dq. How many charges? Infinite charges. Each dq charge will create a potential on its axis. This is the axis. Think about it. This is the axis. So each dq charge on the ring will create a potential over here. A potential over here. Each dq charge will create a potential over here. I hope you can visualize that. Yes, I hope you are able to visualize that. So here is my dq charge, let's say, and that creates a potential here. So let me just draw a line that creates a potential here because of that. And what is this distance going to be? It's going to be root of r square plus x square. So potential due to dq charge, all right, how much will it be? It will be dv, and that dv, because it's potential due to a dq charge, it will be k. Remember, I just told you the formula, k q by r. What is the distance? The distance is root of r square plus x square. I hope you see that. I just told you the potential due to a point charge. Just think about it. I just told you potential due to a point charge is nothing but kq by r. So that's all I have done. So potential due to the dq charge will be k into the charge divided by the distance. That's all I have done. Now, you don't need the test charge, Bhargav. You can do it by the test charge approach, but it will be lengthy. I am skipping the test charge approach because I already know the formula due to a point charge, the potential's formula due to a point charge. Now, think about it, the total value of the potential due to all the charges. So, I'll just say, so due to the ring is nothing but sum of, potential due to point charges. So, basically, the potential of the entire ring is integral of dV, and integral of dV means k is a constant. Even these people are constants. R is a constant, x is a constant. So put them outside the integral. So k divided by root r square plus x square, integral of dq. Now what is the integral of dq? Integral of dq, think about it. No problem, Sanjay, join in. You can always replay back the same part. Okay, so think about it. Okay, now basically integral of dq means add all the charges. If you add all the charges, what will you get? Q. So hence the answer will be kq by root of r square plus x square. That's the value of potential, guys. That's the answer. That's the answer. Is that clear now? Is that clear, everyone? Understood? Integration of dq means dq, 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 dq. So actually there is no hard integration out here. Very good, Bhargav, Keshav, Monkey. Excellent. So remember this formula, very important formula out there. Okay, let's start doing some problems coming up on your screen. Get ready, guys. Some questions are coming up on your screen. The potential difference VB minus VC between 2 points from C to B, does it depend on the path? How you go from C to B? Does it not depend on the path, or does it not have a unique value independent of electric field? What do you guys say? The potential difference between 2 points, what if the angle becomes 90, sorry. What if the angle becomes 90? Will the potential be 0? I'm not sure, Aryan, which angle are you talking about? Alright, so if you are saying that the point is at the center of the ring, the potential will not be 0. Understand that potential will be there. Okay, very good. Let's see this. Yes, easiest integration of mankind. Yes, potential difference. Come on, Monkey says A. Come on, all the warriors out here. Let's see whether you can answer this. Keshav says A. Come on. Kajal says does not depend on the path. Even Bhargav says so. Yes, looks like, I don't know. All right, the correct answer is actually does not depend on the path. Very good. Remember, potential, all right, potential depends on arrangement, the configuration, and it is a scalar quantity. It's a scalar quantity. So if I have some value of potential here, let's say 2 volts, and some other point has 5 volts. Now it doesn't matter how I go from this point to that point. No matter how I go, I will always get the same potential difference. Does not matter on the path. It's independent of the path. Keep this in mind. And field or electrostatic forces are conservative forces. Keep this in mind. This is conservative forces. And if you remember conservative forces from your 11th standard, you will remember the property of conservative forces is the work done does not depend on the path. It is independent of the path. Keep this in mind. Yes. Oh, I think somebody already said that. Yes, Monkey, potential is conservative in nature. In fact, remember this now. Electrostatic force, all right, electric force. What kind of force is it? It is conservative force. Conservative force. Keep this in mind. All right, electric force is conservative force. It's not path sensitive. So if I start from a point and if I come back to the same point, then the total work done will be how much? If I start from a point and come back to the same point, how much will be the total work done? Come on, everyone. Let me know the answer. Yes. Yes. What will be the answer? Come on, everyone. Let me know. That's the definition of conservative force. If I start from a point and come back to the same point, what is the total? Yes, gravitational force is also conservative force. Yes, bilkul. Even spring force is conservative force. So what will be the work done? Come on, I'm waiting for you. I think there is some delay out there. Yes. Potential necessary. Potential is not a force. The field due to potential is conservative. Understand that. Potential is energy, related to energy. Yes, very good. Zero. Excellent. Let's move ahead. Correct. Yes, the answer is zero. Okay, let's get ready for the next question. When a proton with certain energy moves from low to high potential, then the kinetic energy will decrease. Yes or no? What do you guys say? And the direction of the field is always opposite to the potential gradient and work is done against the field. What do you guys say? Are these statements correct? Are these statements correct? And is the reasoning also correct for the assertion? What do you guys say? Yes or no? What do you think? Assertion is correct, reasoning is correct. So think about it. I have a proton and I go from low potential, okay, low potential. So I'm taking a proton and taking it from low potential to high potential. Come on, think about it. Come on, think about it. What do you think will happen? Will the kinetic energy decrease or increase? And is the direction of the field opposite to the potential rate at which the potential changes? Come on, think about it. Well, I'll tell you what. Every time electric force, all right, is such that it will go from high potential to low potential. Keep this in mind. In fact, I've told you this. I just showed you the diagram of positive charge. For a positive charge, the field, all right, the field is like this, if you have noticed. And how does the field travel? It travels from high potential to low potential, because always everything around you wants to decrease their potential energy. So field always travels, the electric field is always directed towards the lower potential. Keep this in mind. Okay, so this is very important thing that you're learning from this problem. So the field will always be from high potential to low potential. If the field is in this direction, the force, remember the force I had told you, charge into the field, the force will be also in the direction of the field. And this is a positive charge, so force will be here. So if the velocity is in this direction, the velocity is in this direction, if the charge is going there, the force is going here, so what will be the direction of the acceleration? The acceleration will be directed this way, and if the acceleration is opposite to the velocity, what will it do? Its kinetic energy will obviously decrease, and it is correct. Yes, I hope this is clear. And if you see, the direction of the field is opposite to the potential gradient. Now the meaning of the line potential gradient is rate of change of potential with distance. Do you see the potential is grading up? This is the grading up of potential from low to high, and the field is opposite to the potential grading up. So hence work is done against the field, so hence reasoning is also correct. Yes, I hope Munna bhai, it's clear. Yeah, it is actually explaining. Yep, very interesting question, beautiful question, so many concepts in this particular question. Remember all these concepts, and they should be all there in your notes, and I hope you guys are making notes already. Okay, let's get going to the next one. You have 4 points A, B, C and D. Look at them. A, B, C and D. The charges are over here. Okay, the charges are over here. In case the diagram is not yet clear, let me just show that diagram for all of you. So it looks something like this, guys. You have, yeah, 2 perpendicular lines. This is D, this is B, this is A, this is C. And then you have 2 charges, one over here, which is plus Q, and the other one over here, which is minus Q. The question is, which of the following is true? Potential at A, B, C and D. And the distances are equal. Please keep this in mind. this distance is equal to this distance is equal to this distance is equal to this distance. This is equal to this is equal to this is equal to this. All of them are equidistant. Keep this in mind. Come on, think about it. All of them are equidistant. Come on, come on, come on, come on. Okay. Yes. Hello, Chandrasekhar. Welcome aboard. Yes. Come on, come on, come on, come on. Think, 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 think. Some of you are saying B. I don't know. Well, let's figure it out. Guys, first of all, look at this. If you are at this point or this point, at D or at B, what I see very easily is that this point is at the same distance from the negative charge as that of the positive charge. So because of the positive charge, if it gets, for example, plus 5 volts because of the positive charge, example. So because of the negative charge, also it will get 5 volts but with negative sign. So what will be the total voltage? Think about it. The total voltage will be 0 volts. Is that clear? So D will have how many volts? 0 volts. Example. Yes. Great. Now, Abhishek, we are doing class 12 syllabus. We are doing 0 to hero series. We are doing killer 5 series. We are doing all kinds of series. So remember, there are 11 to 12 standard students also. So for them, we are doing these Pathfinder series. All right. Great. Now think about it. Think about it. The same is also applicable over here. This will be also 0 volts. This will be also 0 volts. Correct? Because this charge and this charge are again at the same distance from positive and negative. Okay. Now let's go to the other one over here at A. Look at that. A is closer to the positive charge and farther from the negative charge. So because of the positive charge, it might have plus, I don't know, 7 volts because it's closer. But because of the negative charge, maybe it has minus 3 volts. So the total sum, how much will the total sum be? Guys, it will be plus 4 volts. Do you see that it is positive? Example, I just taken numbers. And the same thing if you do for C. C is closer to the negative charge. Maybe it has minus 7 volts because of the negative charge, and because of the positive charge, maybe it has plus 3 volts. So totally it has minus 4 volts. Now, doesn't it become easy to arrange all of them? See, look at this. It becomes very easy to arrange all of them. So A has the highest voltage. You can see that. Then B and D have the same voltage. B and D have the same voltage, 0 volts. And C has negative, which is the least voltage. So hence option number B is correct. Very good. Looks like some of you got it. Excellent, excellent, excellent. Yes. Let's get going to the next question. Beautiful question based on simple logic. That's the answer, B. Guys, this is how the wave platform looks like. Some of you are asking. Sugandhana, please, I request you to watch the replay again. Just rewind back. Even in the live class, you can switch to the replay mode. You can take the slider and come back, all right, again and again. Or even you can visit the same part even after the session ends. Don't worry about it, okay? Just concentrate. You will understand and get a hold of it. Don't worry about it. So this is how the wave platform looks like. The quizzes, you can see that there is quizzes. All right, there are animation slides, obviously, all of that. This is where the chat happens. You can see that. So this is where the teacher is visible on the side. So the main focus is on the content out there. And you can see that you also have a Q&A section out here where you can ask any kind of questions to the secondary teacher. And you can, get all your doubts cleared. And, after the class also, you can take pictures of your doubts. You can send it across chat with our doubt experts and get your doubts resolved from morning till evening. And there is no limitation on number of doubts that you can ask. You can ask it from any book, NCERT, HC Verma, up to you, and get all your doubts instantly answered. And these are proper subject experts, so you know that the answers are correct and you get proper guidance out there. So let's get going to the last part of today's session. Get ready, guys. So what do we have? Last thing, relation between potential and energy. Relation between potential and energy. Let's do this. Last part. Guys, think about it. I just told you potential is potential energy by charge. Remember, I just told you potential is potential energy by charge. Correct? So potential is potential energy by that test charge. Remember that? Now if I take that charge over there, I'll get energy is potential into charge. That's what I have done. That's what I have done over here. Look at this. Energy is potential into charge. Now this is the relationship between potential and potential energy. What it means is that, guys, imagine you have some charges, positive, negative, I don't care. And you are at some point, and because of that charges, you get some potential, some volts, 100 volts. Because of these charges, you get some 100 volts of potential here. Now you actually place a charge there. And now you move that charge. So when you reach a new point, that new point will have a new potential. So do you see, because you have moved the charge from one potential to the other potential, understand there will be a change in the potential energy. So guys, imagine due to these charges, the potential is V1. So this is, let's say, the initial potential energy due to these charges. And V2 is nothing but the final potential because of these charges. This is actually a charge which has been moved along this path. You move this charge along this path. The change in the potential energy is given by this formula. So delta U is QV. What is V? V is the potential difference. Keep this in mind. So what is V? V is potential difference. V final minus V initial. Keep this in mind. V final minus V initial. So that's what it is. Okay, come on, Nancy, wake up. Yes, please. Okay, great. Is HC Verma sufficient for JEE Mains, Lata? Maybe not. You need more books, bacha. Okay, you need previous year questions. In fact, there is a separate session mentioned as to which books are needed for JEE preparation and all that. It's there on our channel. Okay, so keep this in mind. Let's get going to the last 2-3 questions coming up on your screen. Come on, guys. A charge is at the center of an arc. And of a semicircle of a diameter AB. Okay, so there is a charge at the center of a semicircle of diameter AB. The work done in moving a charge Q along the semicircle is W1, and work done in moving from this point to this point is W2. Then compare their work and which one is equal, not equal, equal to 0. What do you guys say? Think about it. Wow, we have now people from Mauritius to welcome aboard. Mauritius, beautiful country. I have been there almost some 7-8 years back. Beautiful place. Okay, come on. Let's do this. How many of you can get this very easily? Let's think about it. So you have a charge at the center of a semicircle. You move up another charge from here to here, and then from here to here. Compare the work. Guys, is it equal? Yes, it has to be equal for sure. And will it be not equal to 0 or will it be equal to 0? Think about it. I feel it will be also equal to 0. Reason, you have that charge over here. This distance is equal to this distance. Because of this charge, the potential at B, and because of this charge, the potential at A will be equal, because reason, distance is same. Remember, this charge to B and this charge to that, the distance is same. So guys, the potentials are going to be equal. Keep this in mind. So potentials are equal. So potential difference 0, work done 0, energy change 0, work done, everything 0. So all of them are going to be 0, and hence this is the correct answer. Very good. I hope this is clear. Okay, let's get going to the next question. Come on, quickly. Yes, Wazim sir is going to be here at 10:30. Calculate the work done by field when a charge, all right, is moved from B to A along a curved path. Potential at A is 200 volts. Potential at B is potential at A is 200. Potential at B is 100 volts. Charge is 0.05 coulomb. Length of this segment 10 centimeters. length of the curved path 20 centimeters. Let's see how many of you can do this. Well, it's not exactly, Sandeep, for Cambridge exams. This is for all the competitive exams of 12th grade like JEE, NEET, Olympiads, board examinations of 12th, and all the other 12th grade K-12 competitive examinations specifically in India and around the world which are of similar level. All right, so that's what we do. Yes, let's do this. Oh, some of you are saying this is already a Laddu question. So guys, think about it. Okay, so I'm not sure, Sandeep, over there, I'm not sure what kind of exams you prepare, and I'm not sure whether people in Mauritius also do prepare for the Indian examinations, or do you guys just prepare for, SAT or something, I'm not sure. Okay, come on. Yes, one, see, I did say that. It's up to you whether you want to stay awake and watch or you want to watch the replay. It's up to you, see, all right? Cool. 5 joule, all right, let's see. Guys, I'll tell you which information is rubbish, not necessary. This is not necessary. This is not necessary. I don't care about this. So remember, change in the potential energy is Q into potential difference. Charge is 0.05 coulomb. Potential difference. Final minus initial. What is the final potential energy? You are going from B to A. You're going from B to A. This is initial, this is final. So final potential is 200, initial potential is 100, and that's going to give me basically 5 joules. So my energy has increased by 5 joules. So obviously the work done is also 5 joules. Yes, that's the answer. So whatever energy has changed has also come from the work which has been done. Very good. Excellent. Let's get going to the next one. All right. Last question coming up for you. Electron of mass m, charge E is accelerated from rest through a potential difference V in vacuum. Then find the final velocity. A mass charge E has been accelerated through a potential difference V. Then what is the velocity, guys? Let's do this. So basically I'll tell you what. If you take a charge, okay, so let's say this is a charge and you take it from one point to the other, and potential difference, the potential difference is, where is it? Potential difference is capital V. Then understand the whatever change in electrical energy, potential energy will come, all right, whatever change in the electrical potential energy will come, will be basically also the change in the kinetic energy. Keep this in mind. The change in the electrical potential energy will also be the change in the kinetic energy magnitude wise, because the total energy has to be conserved. Keep this in mind. Total energy has to be conserved. So magnitude wise they will be the same since energy is conserved. So the change in the potential energy is also the change in the kinetic energy magnitude wise. So what is the change in the energy? Well, that's charge into potential difference, and change in the kinetic energy, well, that's half m velocity square. Now just shift it. So you're going to get 2q capital V divided by m is equal to v square. So v will be root of that. So look at this. I think this should be the option. Is that understood? Yes, conservation of energy. Hello Pranav Sriyag, welcome aboard. Yes, very good, excellent. So this is your question for homework now. You have to leave the answer in the comment section. You will get the answer for this question only in the PDF. And where is the PDF? It's there in the Telegram group. So do not forget to check out the Telegram group. The link for joining the group is there in the description box below. This is your homework question out there. All right, and guys, do check out our pro subscription, because these are the toppers of JEE Mains first attempt, 99.96, 99.97, 99.91 percentile, all these students from this year. And if you want to be here, if you want your face to be here, and believe me, it is possible, and I'm pretty sure most of you want to do that, do check out our pro subscription, because you're going to get a lot of micro courses, lot of preparatory courses for KVPY, regular boards, even mains, advanced, everything under one roof. You don't have to go anywhere. It's like joining Hotstar or Amazon Prime or Netflix where you just pay the subscription and all the shows are available for free of cost. So you don't have to pay every time or shell out money every time for watching a show or a movie. Same thing happens over here, and all this at the cost of just a meal per day, guys. If you calculate the cost per day, it's hardly the amount you spend on your meals. Trust me on that, because if you see the price and the offerings that you get, like the micro courses, doubt solving, test series, assignments, the hard copy of the material, everything available just for, after 10% off, it's 43,739 rupees for whole year till your JEE Mains attempt next year. Yes, for the whole year. This is a price, and you get this price only when you use the coupon code SHHPRO. So you can find me over there in the micro courses and even in the toppers batch out there. So a lot of details are mentioned in the description box link. Do check it out, and do check out the PDF which will be uploaded on the Telegram group as well. Thank you for loving this session, and in case you haven't loved this session, please hit the like button and hit the subscribe button. I'll be seeing you tomorrow morning at 7 o'clock for Zero to Hero series. So get ready for waves 7 o'clock sharp. Bye bye. Take care.